Good morning to all students. So, good morning to all my dear students. So today we are going to start Unit 4. 3 units we successfully completed. Then already Unit 3 assignment also is posted in LMS. So all of you go through that, and then we have to submit the assignment within that date given. It is given on second or third, right? By the end of the third, you can submit the assignment in PDF format. You have to upload in that, right? Okay. Then next, 3 units. I will just summarize the what we discussed in 3 units. The first unit we discussed about the mechatronics. Key elements of mechatronics is very important, and we discussed about the mechatronics design process. What are the steps we have to consider for a mechatronics product to design? And then next we discussed about the microcontrollers, right? That is also used in this mechatronics design process, one of the element. And we discussed the various sensors and transducers. That is velocity sensor, displacement sensor, acceleration sensor, position sensor, and temperature sensors also. Temperature sensors, in that we discussed about thermocouple, RTD, resistance temperature detector, thermistor. And next we discussed about some sensors and transducers, that is pressure sensors, right? That is a diaphragm pressure gauge. And also we discussed so many level sensors also, level sensor, fluid flow sensor, that means either a liquid or a gas sensor, either liquid or a gas flow sensors, right? Like that we discussed so many sensors in that first unit, right? In the unit 2, we discussed about solid state electronic devices. In the solid state electronic devices, we discussed about the diode, that is PN junction diode, forward bias, reverse bias, and the transistors, NPN transistor, PNPN transistor. And then next we discussed the field effect transistor. In that two types are there: JFET, junction field effect transistor, and MOSFET, metal oxide semiconductor field effect transistor. And we discussed about diac, triac, right? And operational amplifiers, different types of operational amplifiers: differentiator, integrated differential amplifier, buffer amplifier. And we discussed about filters also, right? Filters: low pass filter, high pass filter, band pass filter, band stop filter. So these are all in unit 2. And then next in unit 3, so we discussed about hydraulic and pneumatic actuation system, hydraulic actuation system, pneumatic actuation system, electro hydraulic actuation system, electro pneumatic actuation system, electro hydraulic servo system, or electro pneumatic servo system, and mechanical actuating systems, electrical actuating systems, the basic principles, and what are the components, what are the valves, what are the symbols, like this we discussed in this unit 3. Then now we are going to discuss uh, in unit 4, we are discussing about this is completely digital electronics and systems. Today we are going to discussing about introduction to digital electronics and system. That means unit 4 overall introduction of syllabus of unit 4 introduction. Then we are discussing about we will go for discussion on digital logic control, right? So this is introduction to digital electronics and the systems and digital logic control. Today it is the topic. That means the introduction of a unit 4 syllabus and digital logic control. And the unit 4, this is also very simple syllabus. Likewise, unit 3. Same here also, only 5 topics are there. Here 5 topics are not, only 4 topics are there. In the examination, especially in the end semester examination, if you thorough in unit 3 and unit 4, you can uh, easily answer the question. Here in the unit 3, what I told to you, only 5 topics are there, right? Hydraulic actuation system, pneumatic actuation system, electro-hydraulic actuation system. That means electro-hydraulic or pneumatic. So that means here the 2 components changes. I told to you that electric motor drives the compressor in pneumatic, electric motor drives the pump in hydraulic. That is the difference. We have to write down the component name of compressor and the component name motor, pump, right? And that is the 2 topics, 3 topics, right? Electro-hydraulic servo system. And the next mechanical actuation, electrical actuation. That means only 5 topics. Same here also, same, only 4 topics are there. Especially no, 4 topics only there. In my consideration, only 2 topics. One is here see PLC, right? Here PLC, right? Program logic controller, PLC, programmable logic controller. This is the PLC, programmable logic controller, right? And microprocessor, microcontrollers. That means this is microprocessor, right? And this is a microcontroller and program process control, program logic control. That means only 4 topics. So of course, digital logic controller is there, 1, microprocessor 2, microcontrollers 3, and process control 4, and program logic is 5. So of all these 2 are very major topics. So microprocessor is a major topic and PLC is the major topic. Right? So here PLC, right? PLC is the major topic, expected question. 100% expected questions in 1 or 2 sets. Similarly, microprocessor also expected questions in 1 or 2 sets. Here there is no other option. Only in the syllabus they have to give in this way. So now we will discuss, right? So in digital electronics and systems, digital electronics means what we discussed in the unit 2. That is transistor circuitry, and in digital logic control, and here see digital electronics and systems. Digital electronics and digital systems. And digital systems here, digital systems means computers, digital electronics and systems. Digital electronics already we studied, right? Now, and the systems here, and the systems means digital systems. That means computer systems, digital computer systems. Digital logic controller. Here the logic controller is nothing but AND gate, OR gate, NOT gate, NAND gate, NOR gate, like this. There are several gates are there. That is input or the binary codes, that is 0 and 1. We can get the output of binary. All of you know that already you studied C language. I think you know very well the binary codes. And the microprocessor, that means the function here, the total computer is working on microprocessor, right? Here we are going to discussing about the microprocessor. All of you know that microprocessor, right? So I will discuss there before what is the digital computer, that means computer, what are the major components. Here the three major components, all of you know that, right? Input and output devices. One, that is a keyboard, mouse. Output devices is nothing but a printer, right? Monitor is the output. That means input output devices. And CPU is the main component, right? CPU inside the microprocessor, right? Processor, right? That is the major element in CPU that we will discuss the fundamentals about the computer, digital computer. And microcontrollers, there are several microcontrollers there. P controller, that is a proportional controller. PI controller, that means a proportional integral controller. PD controller, that is a proportional different derivative controller. PID controller, proportional integrating and differentiate. That means PID controller. The four types of controllers are there, microcontrollers. With the help of this microcontroller, we can control the process of a machine or a function of a machine. And programming process controls, what I said now, the program, this programming process controllers are there. These are controlled by these microcontrollers. This programming, right? So microcontrollers are programmed, right? The programming. These controllers are programmed. This will control the process controllers. Controller is in a machine or a equipment or a device controls the process. It means it controls the operation of a machine. That means the output may change, the output may vary. And programmable logical control. This is a very, very important topic. This programmable logical controller and microprocessor. These are very important, this programming logic. Here, and then my advice to all of you nowadays, this PLC plays a major role. PLC plays a major role. That means this programmable logical controller is used in industrial automation, most widely used in industrial automation. That means PLC means it is having some ladder logic diagram. What I say, why here this is linked in unit 4, this is linked with unit 3. This unit 4 is linked with unit 3. This programmable logical controller is nothing but it is used to prepare or to write a program on, for example, in hydraulic actuation system or pneumatic actuation system. Same, similarly, I will tell you, right? Same, I will see here this PLC linked with hydraulic and pneumatic, right? Same, this one, for understanding purposes, I will tell you in a brief manner about what you studied in third year, right? You studied third year about lathe machines, right? You studied lathe machines. In the lathe machines, so what you are doing, you are performing so many operations, sequence of operation, facing, turning, right, knurling, threading, and then lastly we are doing even the completion of the what you are doing, parting, right. So all these operations you are doing manually, right? Yes. So now the technology is updating. Next, what we are doing. Next step we are going for computer numerical control, what you are studying this semester, that is a CAD CAM part programming, right? Part programming. So you are writing a part programming in NC part programming, right? So the tool name and then processes, and then you are giving a codes, right? Or part programming, right? Part programming. And then writing the program in so software about NC part program, and then you are feeding to CNC machine. So once if you are writing the program, then automatically when you fed the CNC machine without any human involvement, all the operations carried out on the job, and then we are getting our, lastly we are getting our desired piece. Same similarly here also, same. Here, programming logical controller is the nothing but a part program, comparison, part programming. You are writing a program in ladder diagram. So in this, some Pico soft are there, Siemens software are there. So we are writing on that. And then we are feeding to a system. What is that system? Hydraulic actuation system and pneumatic actuation system. So automatically we can get the functioning is going on in the actuation system. Same, that is here computer numerical control is the machine. Here in this hydraulic actuation system or pneumatic actuation system is the system, the comparison. And then in that we are writing part programming. In that we are writing programming in PLC, programmable logical control. Now are you understanding? See here, programmable logical controller is nothing but we have to write a program in ladder diagram such that that program we have to feed it to the hydraulic actuation system or pneumatic actuation system. Without human involvement, it will perform. So if you take hydraulic actuation system or pneumatic, it is semi-automation. If it is combined with PLC, it is fully automated. It is fully automated. Now you understand about programming logical controllers, right? Programming logic controllers is nothing but it is a digital computer only. It is a computer. Same in the NC part programming, what we are doing in the computer with the help of some so-and-so software, you are writing a program to perform some sequence of operation on the job. Same similarly here also. PLC, it is nothing but in the computer, one software is there. That is nothing but programmable logical controller. We have to write a program, the ladder diagram, and then that program we have to feed it to the, we have to give to the hydraulic actuation system or pneumatic actuation. Thereby, the single acting cylinder or double acting cylinder will activate. That means it will move. That means the piston will move. To and fro motions. If it moves to and through motion, then we can indicate it is A plus. When it is written back, it is, we can consider A minus. That means A here, the name of the cylinder we are giving A plus A minus. That means the cylinder A is moved forward, that is A plus. The cylinder moves back, that is A minus. If you take the cylinder B again, in the industries, there are so many cylinders like that to move the product with the help of the piston from one point to the other point. There are so many are there. Even the lifting system also. I seen in Hindustan Cables Limited, one lifting system is there. One lifting system, that means bobbins. Bobbins will lift it up from one point to the other point, right? It is stored in the temperature. That means here in this lifting, this hydraulic and pneumatic actuation systems are there. That means the piston will push us even 100 kgs of weight and 200 kgs of weight to some distance, to lift up some distance. And then there the bobbins will store it at one place. Like that example I am saying there, the activation, all the things will be with the help of this PLC program. For nowadays, it's very, very important. Once if you learn that PLC software very much, then you can get a good job. Maybe in industrial side, of course, in Singapore side, it's a very, the PLC is a very demand in Singapore side. There, the PLC coaching, these coaching centers on this software, it's very less in overall India. That's maybe in Mumbai, but in, of course, maybe in Bangalore also it is there, but in Hyderabad it is not there. I think all of you know that if you see the newspaper, there we can see, we'll give the training program, certified training program on PLC and SCADA. They will SCADA. These both are belong to ECE only, completely ECE. SCADA, but SCADA is not required. But in our mechanical, it is this PLC is linked with mechanical, but PLC is purely ECE subject. It is a ECE subject, programmable logic controllers. But it is this programmable logic controller is linked with the mechanical devices. Mechanical devices. This is nothing but programmable logical controllers is nothing but it is a program. We have to feed it to the either hydraulic or pneumatic activation system. Thereby, the actuation will take place without any human involvement. What we discussed in Union 3, hydraulic and pneumatic actuation systems, so those are semi-automation. That means with the help of the compressed air or the pressurized liquid, here the linear actuator, that means the cylinder piston will move to and from motions, where without the need of even some small involvement of human also, with the help of this PLC, it will be fully automated by writing a program. And then here the PLC versus computers, right? PLC versus computers. That means what is the differences between the PLCs and normal computer? We will discuss the difference. It's very, very important that that difference also. So many times it is asked 4 marks. And applications. What I said, the applications. Wide range in industrial automation. In industrial automation, wide range. So nowadays, maybe after 5 years, almost all industrial process controllers. Here, see this process controllers, right? So we have to write a program in PLC. Right? We have to write a program in PLC. Right. So now it is clear. So now we'll go for the today's discussion. Digital logic control, right? Digital logic control. So 1 minute, wait 1 minute. So okay, now we'll discuss about this just introduction on digital electronics and systems. Digital circuitry, if you see here, digital circuitry, that means digital systems. Here in the syllabus, first topic is digital electronics and the systems. Systems here means digital systems. Digital circuitry is the foundation of digital computers. Digital systems means digital computers. Are understanding the syllabus? The first that is digital electronics and the systems. In that, so many are there. Digital electronics and systems. Systems here, what he means, digital system. That means digital computer systems. digital, this is the digital, that is the digital circuitry is nothing but foundation of the digital computers. So in that, several various applications are there. Home appliances, anybody can you post to the home appliances, alarm systems, heating systems, right? Automated machine control, what I said now, with the help of the PLC, that is a digital computer, with the help of the software, we can control any machine. PLC, what I said, any actuation, that means PLC actuation. That is maybe a hydraulic or a pneumatic. Anybody can you tell the home appliances of a digital computer, that is digital systems, digital computer systems? Anybody? Home appliances. Anybody? Fast. And inventory management, storage, and medical electronics. Like that, there are several applications are there. So anybody can you post to the home appliances? Home appliances. అసలు ఉన్నారా లేరమ్మా మీరు? You are there or not? I do not know. So I asked you here now 3 or 4 times. This is simply post no sir. Like that also you can post. So forward post cheyaledu. Micro oven, right? Very, very good. Number 311 oven, right? Very good. And 308, very, very good. Oven. Induction stoves, very, very good. Electric induction stoves, electric stoves. These are all digital computer. That means small monitor is there, right? Microcontrollers, right? Induction stoves, very good now. Micro oven, very good. And washing machine, right? Washing machine is also. And next, refrigerator, right? Very good. Very good, refrigerator. పెద్దది మర్చిపోతున్నారు. స్మార్ట్ టీవీ వాటర్ ప్యూరిఫైయర్, రైట్? ఆర్ఓ వాటర్ స్మార్ట్ టీవీ, రైట్? సో వితౌట్ ఎనీ టీవీ కనెక్షన్, విత్ ద హెల్ప్ ఆఫ్ ద మొబైల్ యూ కెన్ లింక్ విత్ ద కంప్యూటర్. ఇట్ ఇన్ అదర్ వర్డ్స్ దిస్ వీ కెన్ ఆల్సో డిజిటల్ వాచ్, రైట్? వెరీ, వెరీ గుడ్. డిజిటల్ వాచ్, దీస్ ఆర్ డిజిటల్ systems. These are the digital computer systems. All that. Home appliance, digital watch, very, very good. Digital watch, air conditioner. So these are all digital systems. Digital, we can also call digital computer. Here means, I am saying that digital computer systems means somebody thinks that it is not a computer. No. Digital computer systems means it is nothing but the monitor is there in that with the help of some operations, the help of the remote, it will be operate. Microcontrollers, right? Inside microcontrollers. So yesterday we watched digital control AC, right? Right, it is there. AC, air conditioning, it's right, absolute right. These are all digital systems. The home appliances, right? Oven, or water purifier, right? Heaters here. I'm writing heater, geysers, right? Geysers are the already in our household, it is there. Xerox machine, very, very good. That is office applications, right? Xerox machine, absolute right. It's a 335 lateral entry, Mohan Sai. Xerox machine, right? Very good. Digital Wi-Fi, correct. So now there are so many applications are there, right? 341 air conditioner, correct, and AC, right? 326, and the next water purifier, correct, right? Refrigerator, right? Induction stoves, all this, all right. Micro oven, right? All are right. And TVs, smart TVs, right? CNC machine, right? That is, I'm asking about the home appliances. Right? Digital welding machine, this is industrial applications, right? Is there any appliances which is used in household? Vacuum cleaner, forgotten. Vacuum cleaner, it is used in the household also. Vacuum cleaner, dust and all, right? CNC machine, digital welding machine, right? These are all in industries, right? Oh, correct, very good. And digital electronics, now we'll discuss about digital electronics evolved from transistor circuit. Transistor circuit. Tra- Transistor circuit. So, one minute, it is not coming. This is transistor circuit, right? Transit lighting sandlers, right? Okay, lightning sandlers, right? Correct, very good. Very good. The help of see here automatically now in inaugural functions, light will be automatically glow by operating a switch. By operating just by operating a switch, automatically the light glows. So no need to go and lamp the light, right? So nowadays remote control lights are understanding. ఒక ప్రమిది ఉంటుందమ్మా, ప్రమిదికి ఒక మూడు నాలుగు పెడతారు ఒత్తులు, inside the oil is there, sesame oil, right? So so what are doing the inaugural function, some esteemed guests, they will light the lamp, right? With the help of the no need, they will stand over there, and then so through some distance only they will operate a remote control automatically, the whatever that light will be, right? Sensor, right? Sensor systems. So these are all applications, right? And in digital electronics evolved from transistor circuitry. That means transistor circuitry means it consists of a resistors, diodes. These are all the digital electronics. And then these are easily fabricated. These digital electronics, what we discussed in Unit 2. And these digital electronics will work with high volt, that means up to 5 volts only, 0 to 5 volts, very less supply needed. So maybe sometimes 12 volts also, 12 volts also, 12 volts. It will work up to 12 volts. So now it's clear. One Google Pay money transition, right? Room sensor, tube lights, fans, right? Very good. These are all digital systems, correct? And Google Pay money transaction, right? These are all digital computer systems, right? The next we'll go for the next one, digital logic control. This is the topic. All in this digital logic control, some gates are there. There are so many gates are there. So don't think in another way this is purely electronics. It's a very easy. If you understand, concentrate whatever I said, then it is very easy. Don't think that is a digital logic controller. SAR is telling that gates, AND gate, OR gate, NAND gate, NOT gate, NOR gate, like that. Don't think on that. It's very easy. Once if you go through that, you think that okay, it is XOR gate, right? XNOR gate also is there, XOR gate. But now we will discuss about only some gates only, not to the depth of the gates. For you, not required the depth of the only. We will discuss 5 or 6 gates, which are fundamental gates, right? So those are the logic control. That is logic circuits, right? So logic circuits, right? Logic circuits. That means a collection of individual logic gates. See here, a collection of individual logic gates connect with each other and produce a logic design known as a logic circuit. What is a logic circuit here? So here the logic gates are there. We can connect or we can combine together 2 or 3 gates, and then we can go for a design of a logic design, and then we can get this is a logic circuit. That means this will control, you can call as a control, can control the processor, you can control the operation, you can control the operation, you can control the process with the help of this digital logic gates. I think all of it. Digital means number, logic means logically, that means mathematical operations, mathematical addition, multiplication, subtraction, like this. Inversion, right? Inverse. So these are all logic, that means logic, control. Okay, this, with the help of this, we can control. Here, if you see here in this, these are the types of logic. That is this logic circuit. That is digital logic circuits. Here, this will make the decision making and memory, and these are the two main right decision making. This logic circuits make the decision making. These gates will make the decision making, and memory also, memory. And the gate has, see, if you see two or more binary inputs, and we can get the single output. All these gates, whatever the gates. If you, for this gate, this is, see here, this is the flow chart, block diagram. Here the gate, see here, if you see the gate, here the input is two or three inputs. That means this is the one input, and this is the second input, and this is the third input. Maybe one input or more than one inputs to the gate, and then we can get the output, only one output. So these inputs are binary inputs. These inputs are binary. Binary inputs means 0, 1. Binary inputs are 0, 1, 0 and 1. These are the only binary inputs. Here for a gate, if you give the inputs 1 or more than 2, that means one input, or maybe 1 or 2, maybe more inputs we have to give the gate to the gate. That means inputs means here binary inputs. Remember this point, binary inputs. Binary inputs means 0 or 1, and we can get the output only 1 from the gate. That the output is also a binary output. That is, see here, this is a binary output. Binary output means it is also a 0 or 1. So now it is clear. Just you have to I am reminding this one, we have to remember. This one we have to remind. Gate, for a gate, input may be 1 or 2 binary inputs, that is a 0 or 1. And from the gate, we can get the output. What is the output? Only single output. That single output is binary output, maybe 0 or 1. Next. So now, before we'll go for the gate, we'll discuss some, right? These are the digital versus analog systems. In the digital, see why difference? Why we have to go for a digital? So in the analog is the old one. So thereby the technology developed, and then now it is digital systems. So why you have to go for analog to digital? So digital is always the output is accurate compared to the analog. That is the major consideration. Almost all the error is also very, very negligible in case of digital. That means almost all desired output only, desired output. And analog, the output that is errors are there. See here, if you see in the digital, it consists of operator. See here, operate and discrete digits, the digital numbers, letters, symbols. That means some mathematical operations, and deal strictly with on and off device, compulsory on and off device. So represent what I said, zeros and 1, binary. Numbers means only 0 and 1. And then if you see in the analog, it measures the response continuously, varying electrical and physical magnitude. That is the temperature measurement sensors, velocity and position, etc. These are all right, etc. Right. These are all analog. So now this temperature sensor also we can go for digital measurements, digital measuring device. So that means these are all not accurate. Parameters are not accurate. Whereas here in this, the accurate. If you see here the digital versus analog, this is a digital watch. See here, if you this is a smooth and continuous changes. That means analog. This is a analog waveform. That is sinusoidal waveform. Analog waveform. This is the digital waveform. This one we can get in the pulse width modulation. Is there pulse width modulation? That is one of the device component in the electronics. That means it converts a sinusoidal into digital. Maybe what I said in the already we discussed analog to digital conversion. The next unit we'll discuss analog to digital conversion or digital to analog conversion or digital to digital conversion also. So this analog means that this sinusoidal waveform is converted into the digital waveform. See here, this is the analog signal waveform and this is the digital signal waveform. Here in this, the waveform is sinusoidal. Here, this the waveform is like this, right? Here, the waveform is on or off, right? Now, if you observe clearly, without this watch, you do not know the time. How can you say 8? It is in between 6 and 7, right? We can say that 8. It is nearer to 8:35, right? 8:35. We cannot tell the correct, the accurate time. Maybe sometimes they will say that 8:33, but we can't know. We do not know, right? Correct time. So if it is like this is analog watch. Now in the digital watch, it is a clearly display 8 hours 32 minutes. 8 hours and 32 minutes. 8 hours 32 minutes. And sometimes the date also will be displayed. But here it is not possible in this date. Of course, maybe in some Titan watches, here some small rectangle box are there. Here in this, it will display date and the name of the day also, right? But here, this is a digital. It will display the date also. Maybe we can go for seconds also. We can display the seconds also, microseconds also can display like that. That is this is the digital watch, right? The digital watch, we can get the accurate, all the parameters we can get accurate, we can get the readings. But in this, we cannot get that type of parameters over in the analog watch. So now we'll discuss tomorrow. Now the time is over, it is coming 12:28. So now we'll discuss this one. If you start means it will take around half an hour to complete this digital logic control. Half an hour, it will take half an hour. So now, okay, right, I will take the attendance. If we discuss, this means digital, that means NOT gate and gate, we'll discuss about 5 or 6 gates, right? It will take time, right? Okay, next class we'll discuss these gates. Now respond your attendance one by one. Respond your attendance in the chat box. Right. Number 1, 4, 5, 7, 8, 9, 10, 11, right, 13 present, 14, 15, 16, 17, 17, 18, 19, 20, 21, 22, 23, 22 absent, 23 present, 24, 25, 26, 27, 28, 29, 29 or 30, right? Then here, all of you see here, the assignment, you have to complete the assignment. Unit 3 already I posted in LMS. All of you go through that, and then you have to upload the assignment in PDF format for Unit 3. Already Unit 1 completed, Unit 2 completed, Unit 3. Now Unit 3 I posted, right? In LMS. Right? All of you check it. 30, 29, 29, right, present, 30, present, 31, present, 32, right, 33, 35, 35, 36, 35. I'm asking about the regular Mohan side. 36 present, 37, 38, 39, 39, 40, 41, 42, 43, 43, 44 present, okay, 45, 46, 46, right, 48, 49, 50, 52, 54, 54, 55, 56, 55, 56, 50, 60, 61, 63, 64, 64 present, okay. 65, right, 66, 67, 68, 69, 69, okay, 70 present, 73, 73, 74, 75, 76, 77, 78, 79, 79, 79, 80, 80, 81, 83, 83, 84, right, 85, 88, right, 89, 90, 89 option, huh? 80 option, 91, 92, okay, right, 91, 92, right, present. Lateral entry 1, 1, lateral entry 1, 89 present, okay. 1, lateral entry 1, right, 2, right, present. 3 present, 4, 4, 5, right, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 16 option, 18, 18, 20, 21, 23, 24, 25, 26, 27, 27, 28 present, 27 option, right, 20, next 29, 29, 30, 31, 32, 32, right, 32, 33, 34, 35, 36, 37, right, 37, 37 option, 37 present, okay, right, 38 present, 39, 39, okay, 40, 41, 40, 43, 43 option time. Okay. 13 to okay 28. 29. Okay. The absentees are now I will read the absentees. 1, 5, 7, 17, 35, 17 present number. 1, 5, 7, 35, 39, 43, 48, 55, 56, 69, 48 present time. 56. Okay, 69, 73, 74, lateral entry 1, 39 present time. Again, I'm reading. All of you listen. The absentees are 1, 5, 7, 35, 43, 55, 56, 69, 73, 74. And lateral entry 1, 16, 18, 27, 18 present. No, right, 18 present. 27, 29, 34, 43. Correct. Again, lateral entries, absentees 1, 16, 27, 29, 34, 43. 18 present. 18 present. Lateral entry 18 present. A given present, lateral entry 18 present. Okay. Anybody else? Anybody? Okay. And the number 5 is suffering from COVID. I hope so. Regular 5. Okay. Thank you, all of you. Tomorrow we will discuss about the gates, different types of gates, right? Okay. Thank you, all of you.